Welcome again to another video about differential equation. Now we are going to see another type of differential equation, which is homogeneous differential equation. And this kind of differential equation has a classic method how to solve them, or a classical technique. Yes, let's get started with how could we know that this is a homogeneous differential equation? A homogeneous differential equation can be written in the form like it's the same as dy over dx is going to be equal to f of y over x. And this function is any differentiable function, and this we are going now to explain how could we know that this is a differential equation. When we found that when we replace every x in our differential equation by ux and every by y by uy, and we will see again that we have, let's see, this is our equation which is started, and you are going to see that we will we will have the same equation. So this is a homogeneous differential equation, and it has a classic method how to solve. Let's see some example to make things clear and to see if you have any percent. Yes, let's see the first example, which is quite easy. It says like x dy over dx is equal to x plus y. Here, as you can see, it's not separable, since if we multiply by dx, we will get x dy and x dx and xy. So it's not separable. We cannot separate y and x. So what should we do here? Let's try to replace x by, let's tx, and y by ty, and we are going to see what's going to happen. So we are going to get tx dy over dx is equal to tx plus ty. As you can see here, we have a common factor, which is t right here and t right here, so we can remove this t in the two sides of the equation, and we will end up with the first equation that we have seen. So this is a homogeneous differential equation. This is a way how to know it is a homogeneous differential equation. Now we are going to see a way how to solve this homogeneous equation. Okay, let's keep the same example. We have x dy over dx minus x minus y is equal to 0. Now what should we do is to replace just we can do a change of variable, like we can say y is equal to tx, and t is a variable, is not a constant, so dy is gonna be the product of the derivative of the product of the two functions. It's gonna be t t dx plus x dt. Yes, and right here we should now we will replace uh, y by tx and dy by this quantity. So it's gonna be x, let me rewrite it down, and it's gonna be x, and we will multiply all the equation by dx. We will get minus x dx minus y dx is going to be equal to 0. So by replacing every y by tx and every dy by t dx plus x dt, we will get like t dx, since this is a dy, dx plus x dt, and minus x dx minus y. I said that's why we replace it by tx, and here it's going to be dx is equal to 0. Now here we have some simplification, which is xt dx with xt dx is going to be cancelled, and we have x squared dt minus x dx. It's going to be x squared dt minus x dx. It's going to be equal to 0. Right here is going to be separable. Every homogeneous equation, when we do this change of variable as y is equal to tx, or we can just do x is equal to ty, it's the same. We don't have no problem, and we will get dx not dy right here. So what should we do is to it's going to be dt minus 1 over x dx is equal to 0. By integrating, it's going to be dt is equal to 1 over x dx. By integrating the both sides, we will get our solution. It's going to be t plus c. We can say t plus c, or c1 is going to be equal to ln x plus c2, and c1 and c2 are two variables, are two constants, so we can just write it as a t plus c. So now we will replace t by its value, as we said before, that y is equal to tx, which implies that t is equal y over x. That's what I told you, which is a function with y over x as a variable. So right here we will get y over x is equal to ln the absolute value of x plus c. By multiplying by x, we will get x ln the absolute value of x plus cx. This is our solution, and c belongs to r. This is our solution for this example. I hope that everything is clear, since they are easy. Yeah, they are easy. Let's see another example. Yeah, this is we are dealing with a separable different, we are dealing with a homogeneous, since there is a rule how to know remark. Let's write this remark. We have the first one is, if you see a differential equation that you need to think of a separable one, then you need to think that it is a homogeneous. We need to organize the method of thinking. So if it's a separable, we are dealing with first method that we have seen. If it's a homogeneous, you need to make it as a separable, since every homogeneous is going to be a separable differential equation, since every homogeneous is going to be a separable differential equation. Yes, this is the first remark. And the second one is how to know it is a homogeneous, by replacing, as I told you, x by tx or xt, and y by yt. This is, and by this change of variable, we will deduce that it is a homogeneous. Then by replacing y is equal to tx and dy, as I told you, x dt plus t dx, it's gonna be a separable. After all that, we are solving a separable differential equation. And let's see another example, which is example number 2. which is, it said that dy over dx is gonna be equal to x squared plus y squared over xy. We can just replace in our mind. So here it's gonna be t squared tx all square, which is t squared x squared, and here is gonna be t squared y squared, and here it's gonna be tx and ty, t times t, it's gonna be t squared, and it's gonna get canceled in the denominator and denominator. So it's gonna be our first equation. What should we do right now is just to replace y by tx and dy by its value. So let's multiply first. We're gonna get xy dy is going to be dx x squared plus y squared. As I told you, by replacing y is gonna be equal to tx, and dy is going to be t dx plus x dt, and we will see. It's gonna be x times tx dy, it's gonna be t dx plus x dt is going to be equal dx x squared plus, right here is gonna be sorry, it's gonna be tx all squared, it's gonna be t squared, sorry, it's going to be t squared x squared, and right here we need to cancel. We have some simplification, x and x squared with this x squared and this x squared. We will going to end up with right here t squared dx plus xt dt is going to be dx plus t squared dx. Some another simplification, and we will end up with uh, t dt times x, and we will it's going to be 1 over x dx. By integrating both sides we will get our solution, which is 1 over 2 t squared plus c is equal to ln x plus c, and now we will replace t by its value, which is y over x, and we have got our solution. It's going to be 1 over 2 y squared over x squared is equal to ln x plus c. So it's going to be 1 over 2 y squared is going to be equal x squared ln x times ln x plus cx squared. And this is our solution for this equation. And I think now it is simple how to know it is a separable and how to know it is homogeneous. Let's see another one. We have dy over, we have x squared dy is equal to xy dx xy dx minus y squared dx. And this equation it's not separable. We cannot separate x and y right here, and it is not it is homogeneous. Why? Because if we replace here, it's gonna be t squared x squared, and here it's gonna be t squared xy, and here it's gonna be t squared y squared, and all t squared are going to cancel, are gonna cancel. So we will end up with our first equation. So we just need to do our change of variable, which is y is equal to x, which is y is equal to x. Directly, it's gonna be x dt plus t dx. Sorry, it's too. It's going to be, I said that y is going to be tx. It's going to be tx squared dx minus, it's going to be t squared x squared dx, and right here we have some simplification, x squared, and we have t dx is going to be cancelled with this t dx, and we will end up with x dt is equal to minus t squared dx. So it's going to be 1 minus 1 over t squared dt is going to be 1 over x dx. So it's going to be 1 over t is equal to ln absolute value of x plus c. 1 over t is the same as x over y. X over y is going to be ln absolute value of x plus c. So now we need to this is a solution, but we need to do some simplification. We will get that y is equal to x over ln the absolute value of x plus c. Yeah, and c belongs to r. I think this is a clear method how to deal with a homogeneous differential equation. And let's see another example. I think this is the last example I'm going to deal with. And we will see more examples in other videos, since this videos is just to get the idea how to solve a differential equation in a certain type. And let's see the fourth example. It says like dy over dy over dx is going to be y plus the square root of x squared minus y squared over x. By replacing x and y by tx and ty, we will end up with some simplification. Here it's going to be ty, and here is going to be t squared, and there is the square root, and it's going to be t, and here t. They all going to be cancelled. So what should we do is to replace y by tx as we will and t plus x dt. Yes, let's see. we will we will have this, and it's going to be x t dt x dy. It's going to be x dy is going, and dy is t dx plus x dt is equal to dx times y is going to be tx plus square root of x squared minus t squared x squared. And now we will simplify things. We have tx dx, this with this tx dx, and here we have x squared dt is going to be equal to, here it's going to be x squared, it's going to be square root of 1 minus t squared, and here is going to be x dx. Yes. Now what should we do is to yes, we have some simplification, which is x, and this it's going to be, yes, it's going to be 1 over the square root of 1 minus t squared dt is equal to 1 over x dx. By integrating the both sides, we will get as you know, sorry, the integration of, as you know, the integration of a 1 over t the integration of 1 over t 1 over the square root of t 1 minus t squared is sine inverse of it's going to be t is equal to ln x plus c, and t, as I told you, is y over x is going to be ln x plus c. And here this is the end for today, and see you in another video with another type of differential equation. I hope that you have understood everything that I said, and see you in another lecture.